Hi guys, I welcome you to my YouTube channel Learning with IBM, and I am solving past paper questions of May-June 2023. This is going to be multiple choice questions. That is going to be paper 1-2, Physics 9702. So without wasting time, let's go to the question papers. So here we are solving this is 9702 1-2, that is May-June 2023. The paper is supposed to be 1 hour and 15 minutes. I'm going to try my level best to keep the time. So it is paper 1, multiple choice questions. I will not go through the instructions. You are used to the instructions. I will straight away go to the questions. Okay, question number 1. A stone sinks in water. What is a possible value for the density of the stone? Of course, since it sinks, then the density of the stone should be greater than the density of water. And we know the density of water is 1000, so the density of the stone should be greater than 1000 kilograms per meters cubed. The density of the stone should be greater than 1000 kilograms per meters cubed, which is the density of water since it sinks. So this one is wrong because this is 800. I think the answer is going to be this one because this is 2000. So this density is greater than 1000, so the answer is going to be B. An object only sinks if its density is greater than the liquid in which it is placed. So gigameters, terameters, micrometers, and picometers are all units of length. Which unit is the largest and which unit is the smallest? So giga is times 10 power 9, tera is times 10 power 12, micro is times 10 power minus 6, and pico is times 10 power minus 12. So which one is the largest? Of course, that is tera. Tera is the largest, so ignore A and B. The smallest is pico, so the answer is going to be D. Two measurements for a solid sphere are shown. Mass is 32.5 plus or minus 0.1 milligrams. Diameter is 1.87 plus or minus 0.04 centimeters. These values are used to determine the density of the sphere. What is the percentage uncertainty in the density? So to begin with, we know that density is mass divided by the volume. And of course, because this is a sphere, the volume of a sphere is 4 over 3 pi r cubed. And of course, we also know that the radius is equal to diameter divided by 2. So I just substitute. So the volume is going to be 4 over 3 pi. Where there is r, I'm putting d over 2. So this is d divided by 2, but it's raised to power 3. So this becomes 4 pi d cubed divided by 3 times 2 power 3, which is 8. 8 cancels with the 4, and this remains pi d cubed divided by 6. So that is the volume. So I'm now just going to substitute in the expression for density. So density is going to be equal to the mass divided by the volume, which volume is pi d cubed over 6. So this becomes 6m divided by pi d cubed. So that is the density. So what is the percentage uncertainty in the density? So since there's division and there is a power, I will deal with the fractional uncertainties. So the fractional uncertainty in density is going to be equal to fractional uncertainty in m, I ignore the 6, plus, because d is raised to power 3, I will say 3 fractional uncertainty in d. So of course I can multiply this side by 100. I multiply this side by 100, it is now percentage. So I will say percentage uncertainty in density is equal for the mass, that is 0.1 divided by 32.5 plus 3 times 0.04 divided by 1.87. And this is going to be multiplied by 100. I'll check with my calculator. So I have 0.1 divided by 32.5 plus this is going to be 3 times 0.04 divided by 1.87. So I multiply this by 100. So this is giving me 6.7%. So this is 6.7%. So the answer is D. An aircraft travels along a horizontal path. Two of the forces that act horizontal on the aircraft are the thrust, force of the engine, and the force due to the wind. The vector diagram for these forces is shown. Which vector represents the resultant horizontal force acting on the aircraft due to these two forces? The resultant horizontal force. The resultant horizontal force acting on the aircraft due to these forces. So, of course, this part must be confusing to people because they said resultant horizontal force, but it was traveling along a horizontal path. So, I'll just complete the parallelogram. So, I'll transfer the thrust force to the top of the other one without changing the magnitude and direction. I'll also transfer the force due to the wind on top of the other one. The force due to the wind is in that direction. The force due to the thrust force is in that direction. So the resultant must be the diagonal force between these two. So the resultant must be force here. So this should be the resultant. So when I look at the answers here, it means the answer is going to be C. The ball travels from point X to point Y around a semicircular track of radius 1.0 meters. So the radius is 1.3 meters. I will join X to Y. This is a past paper question, of course. I answered it in my past paper questions, the topical past paper questions. So the radius, if this is the center, the radius is 1 meter. What is the displacement from X to Y? Of course, displacement is the shortest distance, the straight line distance between X and Y. So that is going to be 1 meter plus 1 meter, which is 2 meters. But then it is displacement from X to Y, so the displacement must be downwards. So 2 meters, it is 2 meters, but displacement is a vector quantity. There must be direction, so the answer is going to be B. 2.0 meters due south. X to Y, it is due south, so the answer is B. A rock is launched vertically upwards from the surface of the Earth, and an identical rock is launched vertically upwards from the surface of Mars. Each rock is launched with an initial velocity 12 meters per second. Each rock then reaches its maximum height above the surface before returning back to the surface. Remember, at maximum height, velocity goes to zero. At maximum height, velocity goes to zero. In both cases, air resistance is negligible. So if before we read the question, if it is a velocity against time graph, every time the graph reaches zero, v is equal to zero, the body is at maximum height. So for Earth, maximum height is here at this value of time. Then for Mars, maximum height is at this point of this value of time here. Because when v is zero, the body has reached maximum height. What is the difference in the maximum heights of the two rocks? So let's start with the first. Let's start with the Earth. Let's start with the Earth. For the Earth, of course, the maximum height is going to be the area under that part of the graph, this area here. So this is going to be a half times this initial velocity is 12. So times 12, base times height. So this height is 1, 2, 3, 4, 5, 6. The scale is 0. The scale is 2 divided by 10, which is 0.2. Then I multiply this by 6, that is 1.2. So this is 1.2 seconds. So times 1.2 seconds. I think this is 6 times 1.2, which is 7.2 meters. That is h, maximum height on Earth. Then on Mars, h is still the area, so this is going to be a half times 12 times the time here is, so this is 2, 1, 2, 3, 4, 5, that is 3.2. So that is going to be 3.2. This is 3.2 3.2, this was 1.2. So this is 3.2. And what is this? A half times 12 times 3.2, which gives us 19.2. So for Mars, maximum height is 19.2 meters. So we want the difference in the maximum height. So difference in maximum height is 19.2 minus 7.2, which is automatically 12 meters. So the answer is A. Which statement describes the mass of an object? Of course, we know that mass is a measure of a body's inertia to change in its motion. It's a measure of a body's resistance to change in its motion, that is inertia. So let's check. Mass is not a force. Mass is not momentum. Mass is the resistance of the object to change in motion, that is inertia, measure of inertia. So the answer is C. A submarine of total mass 3,200 kilograms is at rest underwater. It is at rest underwater. So that means initially the upthrust on the submarine should be equal to the weight. That means initially the upthrust is equal to mg. Initially the upthrust is the mass, which is 3,200 times g, which is 9.81 initially. Then after, total mass of the submarine is suddenly decreased by 200. So after the mass is decreased by 200 by pumping water out of the submarine horizontally in a negligible time, the upthrust acting on the submarine is unchanged, so the upthrust remains the same. So it means afterwards, upthrust is going to be greater than the weight because the upthrust is not changed, but the weight has reduced. So it means there's a resultant force upwards, and the resultant force F is given by mass times acceleration, which this time will be the upthrust minus the weight, because now the upthrust force is greater than the weight. So the resultant force when it is reduced by 200, the new mass is now 3,000 kilograms for the submarine. So the mass is 3,000 times the acceleration should be equal to the upthrust, which remained 3,200 times 9.81 minus the weight, which weight is, because now the weight has reduced, so the weight is now 3,000 times 9.81 because the weight has now reduced. When the 2,000 kilograms is removed, the weight has now reduced to 3,000 times 9.81. So it means the acceleration is going to be equal to 9.81 into 3,200 minus 3,000, that is 200, divided by 3,000 to get the acceleration. So what is the initial upward acceleration? I'll just check my calculator. 9.81 times 200 divided by 3,000. So this is 0.654. 654. So the answer is going to be B. A box in air slides with increasing speed. It slides with increasing speed. It slides, and it is in air with increasing speed down a rough slope. That means there is friction. So there is friction in the opposite direction. I'll call that one F. Frictional force, small letter F. Of course, it is sliding in air, so there is air resistance in that direction. Air resistance. The slope surface exerts a constant frictional force on the box. As the box moves from P to Q, there are changes in the magnitude of its acceleration and the total resistive force acting on it. Which arrow describes the changes? Which arrow describes the changes? Let's say there is a force which acts downwards, and this force I'll just call the forward force FD. Of course, if there is no any other thing acting, it is going to be due to gravity, which will be, if I know the angle of the slope as theta, this force would be mg sine of theta, but I don't need that for now. So the resultant force F, which causes the acceleration, is going to be mass times the acceleration, which is going to be the forward force Fd, which would be mg sine theta if theta was given, but minus the forces acting in the opposite direction, which include the frictional force plus the force due to air resistance. The frictional force is constant, the Fd is going to be constant, but force due to air resistance increases because as the slides, the speed is increasing. As speed increases, the force due to air resistance increases. Those of you who remember, the force due to air resistance is directly proportional to the square of the speed. So the force due to air resistance increases. So since the force due to air resistance increases, it means the difference or the sum of F plus F air increases. So I'm saying F plus F due to air resistance, this one increases, which means that Fd minus that becomes smaller. So Fd minus F plus F due to air, the whole of this quantity here decreases. What does that mean? The resultant force has decreased, and resultant force is equal to ma. So the acceleration has also decreased. So let's see what the question wants. As the box moves from P to Q, there are changes to the magnitudes of its acceleration and the total resistive force acting on it. Which row describes the changes? So we have seen total resistive force increases because the force due to air resistance increases, so the sum becomes greater. So we ignore A and B because total resistive force increases. Then the acceleration automatically decreases because the difference in the forward force minus the resistive force becomes smaller. And remember that difference is the resultant. So the answer is going to be automatically D. Two balls X and Y approach each other along the same straight line and collide. The collision is perfectly elastic. The collision is perfectly elastic. Of course, if it is perfectly elastic, relative speed of approach should be equal to the relative speed of separation. The initial speeds are ux and uy. After the collision, they move apart with the speeds vx and vy respectively, the directions are shown. Which equation is correct? Since the collision is perfectly elastic, the relative speed of approach should be equal to the relative speed of separation. So relative speed of approach is going to be ux. I'm saying velocities to the left positive, to the right positive, and to the right, to the left negative. So relative speed of approach is ux minus negative uy. This becomes ux plus uy. Relative speed of separation is going to be vy minus negative vx. I've said velocities to the left negative. So this gives me vy plus Vx. So we check for this. Relative speed of approach should be equal to relative speed of separation. The answer is automatically A. A rod is pivoted at point O. A force F is applied to the rod at point W as shown. What is the moment of the force F about O? Remember, moment is the product of force times the perpendicular distance. So if this is the force, we need distance which makes 90 degrees. We need the distance of the line which makes 90 degrees with the line of action of the force. So the distance, the perpendicular distance is going to be this one here, which is OY. It is not OW, it is not YW. So what is the moment of the force F about O? So F is going to be, the moment of F is going to be the force F times perpendicular distance OY. So the answer is going to be B. A uniform rod XY of weight 10 newtons is freely hinged to a wall at X. It is held horizontally by a force F, acting from Y at an angle of 30 degrees to the horizontal as shown. What is the value of F? So to find F, we are going to take moments about point X. I'm going to take moments about point X. So this will cause a clockwise moment. F will cause anti-clockwise moment. Since the beam is horizontal, it is in equilibrium, the resultant moment should be zero. That is, the sum of clockwise moments should be equal to the sum of anti-clockwise moments. So this distance here, because it's a uniform beam, its weight is at the midpoint. So this distance is going to be xy divided by 2. So to find the perpendicular distance of F, I may not use this. If you want, you can use this. You can use this distance here. But the easiest way would have been to resolve F vertically upwards, so that it is F sine of 30, so that the perpendicular distance of F sine 30 is xy. Alternatively, you can say opposite and hypotenuse. So that is sine of 30 is equal to the opposite, which is d, over the hypotenuse, which is xy. So still it means d is equal to xy sine of 30. This will be the perpendicular distance. But when I use f sine 30, perpendicular distance is xy. So what is the value of f? So clockwise moments will be f sine of 30 times the perpendicular distance, which is xy, should be equal to 10 times the perpendicular distance, which is xy divided by 2. So xy cancels out, and I have that f sine of 30 is equal to 5. So F is equal to 5 divided by sine of 30, which is equal to 10 newtons. So the answer here is going to be C. Two solid cubes X and Y are made of material of the same density. Cube X has twice the mass of cube Y. Cube X has sides of length X. Cube Y has sides of length Y. What is the ratio X over Y? Okay. So since they have the same density, I'll use the concept of density. So density is equal to mass divided by volume. So um, for cube Y, they have the same mass. So for the first one, for cube Y, it will be mass over its volume. Since the length is Y, so it will be Y cubed. This should be equal to the other one, cube X. Remember, it has twice the mass of Y. If Y is M, then X is twice M. So this will be twice M divided by the volume, which is x cubed. So I have this part here of the expression. So m has cancelled, and I now have that x cubed divided by y cubed is equal to 2, because m cancelled out. If I find a square root, the cube root, x over y is going to be the cube root of 2. What is the cube root of 2? So shift cube root of 2. That is 1.26. So this ratio is going to be 1.26. So the answer is A. A U-shaped glass tube contains liquid of density 2000 kilograms as shown. What is the difference in pressure due to the liquid between levels P and Q? Okay, I am going to just take a common point that is at the same level. According to Pascal's principle, at the same level, the pressure is equal, but the pressure is equal and acts in all directions. Okay, and we want the difference in pressure due to the liquid between levels P and Q. So between levels P and Q, we want this one here, which is 10 minus 6, which is 4 centimeters. So the difference in pressure will be equal to density times G times the difference in height. So this is going to be the density, which is 2000 times G, which is 9.81, times H, which is 4 times 10 power minus 2. So this is 2000 times 9.81 times 4 exponent minus 2. So this is 784.8 pascals. So the answer is going to be A, 780 pascals. A steam turbine is used to drive a generator. The input power to the turbine is Pi, and the output power is P0. The power loss in the turbine is PL as shown. What is the efficiency of the turbine? This is a past paper question. We know that efficiency is equal to the useful power output divided by the power input. If possible, you multiply by 100. So the power output has been given as P0 and the power input has been given as Pi. So the answer here is automatically going to be D. A variable force is applied to ensure that a constant power is supplied to a train. Which graph best shows the variation of the force F with velocity v of the train? A variable force is applied to ensure that a constant power is supplied to the train. We know that power is equal to force over v. So if I make F the subject, F is going to be equal to power divided by v. Now this is a graph, it's a graph of F against v. They've given us a graph of F against v. So that means the gradient, if it is F against v, F is inversely proportional. If the power is constant, F is inversely proportional to v. If power is constant, F is inversely proportional to v. As v increases, F should decrease. So this one is wrong. This one means F is directly proportional to v, which is not true. This one is wrong. It is showing that as F increases, as v increases, F also increases, and then it becomes constant, which is wrong. This one is also wrong. So the answer is this one here. Because we have seen F is equal to power over v. F is inversely proportional to v. As v increases, F decreases if the power is constant. So the answer is A. The block is released from rest and slides distance x down a straight slope. The slope is at an angle theta to the horizontal. Since it is released from rest, initial velocity here is 0. The slope is frictionless and air resistance is negligible. That means the acceleration is going to be g. So the only force acting is the force caused by the gravity. But which force is that? If the weight of the block is m times g, then the force downwards is going to be mg sine of theta. So the resultant force F is equal to m times a, which is only mg sine of theta, which means the acceleration is equal to g sine of theta. That is the acceleration. The question is, which expression gives the final speed of the block? So since air resistance is negligible, I'll use the equations of motion. V squared equals to u squared plus 2as. So we want the final velocity. V is going to be the square root of initial velocity is 0 because it started from rest. So that is 0 squared plus 2 times the acceleration, which is g sine of theta. Then s is the distance through which it moves, which is x. So it means v is simply the square root of 2g sine theta times x, which makes the answer to be automatically be 2gx sine of theta. What is meant by the spring constant? Of course, if we remember Hooke's law, the force is directly proportional to the extension. So the force is equal to K times X. So the spring constant K is force per unit extension. So this means our answer is going to be D. The spring constant K is force per unit extension. A child holds a thin metal wire that is attached to a kite. The graph shows how the extension of the wire varies with its tension. Okay. A gust of wind increases the tension from 100 to 150. What is the change in the elastic potential energy? So of course, the elastic potential energy is going to be the area under the graph. So I will consider the first from 0 to 100. From 0 to 100, I'll call this one E1. So E1, elastic potential energy before, is going to be a half times 100 times 0.3. I'm using the area under the graph. I think this is it 15? 0.5 times 100 times 0.3. I think this is 15 joules. Then elastic potential energy for the hole up to 150. I'm just considering, let me change the color. So I'm considering now the whole area up to 150 for the whole triangle. So this will be a half times a 150 times 0.45. A half times 150 times 0.45, which is 33.75 joules. So we want the change in elastic potential energy. So the change in elastic potential energy is going to be 33.75 minus 15. So I'll subtract 15, and this is 18.75. So the answer here is approximately 19. So the answer is B. A microphone detects a sound wave. The microphone is connected to a cathode ray oscilloscope. The shape of the trace on the screen of the CRO is shown. Which property of the sound wave can be determined by using only the measurement of the horizontal distance on the screen and the value of the control setting of the CRO? The horizontal distance, remember, gives us the period. Period is the horizontal distance on the screen for one cycle times the time-based setting. So this one gives us period, and frequency is equal to 1 over period. So this could be 1 over the length, the horizontal distance times time-based setting. So it is either period or frequency. So the answer is B. Just to go back, if I want the period, I would need the horizontal distance representing one cycle. This is L. Then I multiply it by the time-based setting to get the period, or to get, when I get the reciprocal, I get the frequency. A longitudinal wave is traveling from left to right. Left to right, the graph shows the variation with the displacement of the particles with the distance along the wave at one instant in time. Displacements to the right are positive, displacements to the left are negative. Which labeled point represents a compression? Remember, a longitudinal wave travels as compressions and rarefactions. Then compressions and rarefactions. So for compression, we have particles are at high pressure. For rarefactions, we have particles at minimum pressure. So if I was to sketch a graph, because at compression particles have minimum displacement, almost zero displacement. So here where we have a rarefaction, it is going to be maximum displacement, and here where I have let me sketch this. So here where there is a compression, there is minimum displacement. Where there is a rarefaction, there is maximum displacement. So if I try to sketch this, what's wrong with this pen? Okay, sorry about that. So this is going to be, there is a node, there is a maximum displacement between between two compressions. Then maybe another rarefaction will come in like that. So that means here there is minimum pressure, maximum displacement, maximum pressure, minimum displacement. So we have to choose between B and D. The question is, which labeled point represents a compression? So it is either B or D. But remember, displacements to the right are positive and displacements to the left are negative. And the wave is traveling from left to right. Since the wave is traveling from left to right, it means the first compression we shall encounter is this one at B. So the answer is going to be B here, because here particles are under much pressure. The particles here are under much pressure. Remember, the graph shows the vibration of the variation of the displacement of particles with distance along the wave at one instant in time. So the first compression that we shall encounter is this one at B, where the particles are under much pressure, that is zero displacement. A source X emits a sound wave. Source X emits a sound wave of constant frequency f. Okay, the wave is subsequently received at a stationary detector y. The frequency of the wave that is detected by y is less than f. The frequency at y is less than f. That means if you look at f naught equaling to v over v plus or minus u times f. Since the frequency, the observed frequency f naught is less than f, that means the denominator should be plus. So f naught should be equal to v over v plus u times f. Since the observed frequency is less, it means there is movement away from. What could be the reason for this? Okay, let's see. Between x and y, the wave undergoes diffraction. Between x and y, the wave undergoes reflection. X is moving away from y, x is moving towards y. A source X emits a sound wave of constant frequency f. The wave is subsequently received at a stationary detector y. The frequency of the wave that is detected by y is less than f. Okay, so if f naught is less than f, then it means x must be moving away from y. So that is automatically the answer is C. If it was moving towards, the frequency is supposed to be higher. A beam of visible light is in a vacuum. What could be the frequency of light? Visible light from Rimenera's mother is visiting Uncle Xavier's garden. Visible light has wavelength of approximately 10 power minus 7 in meters, because for red it is 7 times 10 power minus 7. For violet it is 4 times 10 power minus 7 in meters. So I will just use power minus 7. So the wavelength is going to be 10 power minus 7 meters. Of course, we know the speed is 3 times 10 power 8 meters per second. So the frequency is going to be equal to c divided by lambda, which is 3 times 10 power 8 divided by 10 power minus 7. And when you press your calculator, I think this is going to be 3 times 10 power 15. So it means this is far, this is far, this is far. The closest is D. In fact, if I had chosen a different value, if I had chosen a different, if I had put a number in front of 10 power minus 7, I would get power 14. So my answer is going to be D. If I had put maybe, let's say, let me say 2 times, or let me say 7 times 10 power minus 7, most likely my answer would be times 10 power 14. Let me check that. 3 divided by 7 times 1 exponent 15. So it becomes 10 power 14. So if this would be, if I take red, 7 times 10 power minus 7, that is 4.3 times 10 power 14. If I take red light. So the answer there is D. A vertically polarized beam of light of intensity I naught is incidentally normal on a polarizing filter. The transmission axis of the filter is at an angle of 45 degrees to the vertical. So the transmission axis is at an angle of 45 degrees to the vertical. So only a fraction of I naught, which is parallel to the transmission axis, will go through. What is the intensity of the beam of light after transmission through the second filter? So let's check for the first filter. Intensity which goes through the first filter is I1 is equal to I naught cos squared of 45 according to Malsey's law. Malsey's law states that I is equal to I naught cos squared theta. So this, I think cos squared theta, cos of 45, cos 45, but this should be squared. I think that is 0.5, it is a half. So this is I naught divided by 2. That's what goes through the first filter. Then the second filter, I2 is going to be the incident now. This is I1. So it is I1 again. It is rotated until it is 90 degrees. So it is rotated into a further 45 degrees. So this is going to be I1 cos squared again through 45 if I take I1. So this is going to be equal to I1 again divided by 2 because we have seen cos squared 45 is a half. So it means I2 is going to be I1, which was I naught over 2, I naught over 2 again divided by 2, which becomes I naught divided by 4. So this makes the answer to be B. A stationary wave is formed by two progressive waves traveling in opposite directions. Remember, this is stationary. So if it is stationary, then these must be coherent waves, waves of which maintain a constant phase difference. Which statement about the two waves is not correct? No, not stationary does not mean progressive waves. Does not necessarily mean coherent waves. But if it is a stationary, number one, they should be cancelling out each other, so the amplitude will be the same. They should be having the same frequency if there is total cancellation to occur and total reinforcement. So there should be same frequency, same period, the waves should be of the same type. They may not necessarily be coherent. That means they may not be maintaining a constant phase difference, but at some point they may result into stationary waves. So the answer here, because we know that V is equal to lambda times F, to have nodes, if we are to have nodes, the frequency, the wavelength of the two waves should be the same, the frequency should be the same. And if these two are the same, then the speed will be the same. So these three should be the same for the two waves. They should be traveling in opposite directions. So the answer, which is not really very correct, is going to be A. The saying that they must have a constant phase difference may not be really very necessary. As long as they have the same amplitude, same frequency, same wavelength, same speed, same type, traveling in opposite directions. So they may not maintain a constant phase difference. They may not be coherent, but still form a stationary wave. The sound from a loudspeaker placed above the tube causes a resonance of the air in the tube. A stationary wave is formed with two nodes and two antinodes. The tube has height of 60 centimeters. The speed of sound in air is 340. What is the frequency of the sound? So the length of the pipe, L, is a half plus a quarter a cycle. Those are 3/4. So L is representing 3/4 of wavelength. So the wavelength is going to be 4 times L, which L is 60. So that is 60 times 10 power of minus 2. Then divide by 3. I made lambda the subject. So this is going to be the wavelength. What is this wavelength? So 4 times 60 exponent minus 2 divided by 3. So this is 0.8. 0.8 meters. So frequency is equal to V divided by wavelength, which is V is 340 divided by 0.8. So 340 divided by the answer, that is 425 hertz. So the frequency is 425 hertz, so which rounds off to 430. 430 hertz. A continuous progressive water wave travels in a ripple tank, passes through a gap in a barrier and diffracts. The width of the gap is greater than the wavelength of the wave. Remember, for diffraction to be maximum, the wavelength should be very close to the width of the gap. So they say the width was greater, so the width must be reduced. Or the wavelength must be increased. So let's see. Which change causes the wave to spread over a larger angle? That is, what causes the greater um, diffraction? Small decrease in the wavelength. Remember, the wavelength was already smaller. If you decrease it again, it means diffraction reduces further. A small decrease in the width of the gap. The width was bigger, so it should be decreased so that it's almost the same as the wavelength. I think this makes sense. A small increase in frequency. Frequency is inversely proportional to wavelength. Increasing frequency is equivalent to decreasing wavelength. Remember, the wavelength was already smaller, so it means you are making it even more smaller. So this one reduces diffraction. A small increase in the height of the barrier. This one does not relate to diffraction, so the answer is B. If we reduce the wavelength, the size of the gap to be very close to the wavelength, then diffraction is max. The diagram shows a view from above of a double slit. L is monochromatic light. L is monochromatic light source with a vertical filament. B is a barrier with two narrow vertical slits, and S is a screen upon which interference fringes form. The intensity is I at the point on the screen where the center of the fringe pattern forms. Just to remind ourselves, we know that intensity is directly proportional to amplitude squared. That means intensity I'll call it I1, is going to be equal to a constant times the amplitude squared initially. The intensity is I at the point on the screen where the center of the fringe pattern forms. Okay. When one of the slits is covered, what is the intensity at the same point on the screen? What is the intensity at the same point on the screen? So now that if one of the slits have been covered, it means the amplitude is going to be halved. The amplitude has been reduced because the amplitude was due to two slits. Now it has been halved. So for one slit, the amplitude A2 is going to be equal to a half of the first amplitude. So the intensity I2 is going to be equal to K times the new amplitude, which is A over 2, but remember the amplitude should be squared. So this is going to be equal to K A squared divided by 4. But remember, Ka squared was I1, or it was the incident initial intensity. Let me call it I. It was just simply I. So it means I2 is going to be, where there is Ka squared, I will put I, so it will be I divided by 4. So this means our answer here is going to be D. For one slit, amplitude, since it is now one slit, the amplitude must be halved. But then the intensity is directly proportional to the amplitude squared. So the second intensity when we are having only one hole is going to be K into A over 2 squared, which becomes Ka squared over 4. And since Ka squared was I, or it was the incident intensity when there were two slits, so it becomes I divided by 4. The answer is D. Green light of wavelength 550 nanometers incident normal on a diffraction grating. When I say diffraction grating, the first thing to come into my mind is n lambda is equal to d sine of theta, where theta is the angle measured from the central bright fringe. What is the distance between two adjacent slits? That is, we want to find d. Remember, d is the distance between adjacent slits. So since n lambda is equal to d sine of theta, and no, distance between two adjacent slits. Yeah, that is d. So let me begin by finding theta. I think this can be theta. This is called third order, so small n is equal to 3. This is 3, the wavelength is known. The wavelength is 550. We want D. All I need is sine theta. So sine theta, from the diagram, I see that opposite over adjacent, that is tan. Opposite adjacent, I think that is tan. Alternatively, if I want a more exact value, I can find this side because this is a right angle triangle. So this side is going to be the square root of a squared plus b squared. So that is 3.5 squared plus 0.75 squared. So that sine theta, which is opposite, that is 0.75 over hypotenuse, which is the square root of 3.5 squared plus 0.75 squared. That is sine theta. So let me make D the subject. So D is going to be equal to N, which is 3, times wavelength, which is 550 by 10 power minus 7, divided by sine theta, which is 0.75, divided by square root of 3.5 squared plus 0.75 squared. So I'll press my calculator. So I have 3 times 550 exponent minus 7. The root goes up, so I'll simply say times the square root of 3.5 squared plus 0.75 squared. Then divide by 0.75. So I'm getting 7.87 times 10 power minus 4. 7.87 times 10 to the power of minus, no, the wavelength is nanometers. I think this is power minus 9, not minus 7. So I'll just multiply this by 1 exponent minus 2 because it is minus 9. So that is 7.887 times 10 to the power of minus 6. Because this is supposed to be minus 9, since this is nano. Nano is 10 power minus 9. Okay, so the answer here is going to be automatically C. Which charge can be carried by a charge carrier? Remember, charge is quantized. Charge does not take on any random values, but is a multiple of the elementary charge E. So charge should be equal to N times E, where N is a whole number. So N should be 1, 2, 3, 4, and so on and so forth. And the smallest charge is 1.6 times 10 power minus 19 coulombs because charge is quantized. So it means A is wrong. The smallest charge should be 1.6 times 10 power minus 19 coulombs. B is also wrong because when I divide 4.0 by 1.6, I don't get a whole number. Then C is correct. When I divide 4.8 by 1.6, I think I get, let me check, 4.8 divided by 1.6, that is 3. So C is correct, is the whole number. I can check D, 9.1 divided by 1.6, it is not a whole number. So charge is quantized, it takes on values which are multiples of the elementary charge. So this should give us a number which is multiplied by 1.6 times 10 power minus 19. So I divide these values by 1.6 times 10 power minus 19 to see if I get a whole number. So the answer is C. A resistor of resistance R is connected across a cell of EMF E and negligible internal resistance C. Which single change to the circuit would lead to the largest increase in the power dissipated in the resistor? First of all, we know that power is equal to I squared times R. And we know that the current in a circuit is the EMF divided by total resistance R. So the EMF has been doubled. If EMF is doubled, then it means current is also doubled. So if the current is doubled, the power is going to be doubled. So the new power is going to be current is twice I, but squared then times R, which becomes 4I squared times R. So this becomes 4 times the first power. This is power 1. So this is 4 times the first power. Okay. So which single change to the circuit would lead to the largest increase in the power dissipated in the resistance, doubling the value of E? We have seen doubling the value of E makes the power to be multiplied by 4. Doubling the value of R would make the power to be multiplied, I think, by 2 because power is directly proportional to R. So this one multiplies the power by 2. This one multiplies the power by 4. Of course, having E reduces the current. This one reduces the power. Having R, this one also reduces the power. So the answer is A. An electrical cable is made up of a thick strand of copper wire that is surrounded by 8 strands of copper wire. All 9 strands of wire are connected in parallel. Okay, so we have to consider resistors in parallel. A cross-section of the cable is shown. Each thin strand of wire has cross-sectional area A and length L. The thick strand of wire has cross-section area 4A and length L. The cable has total resistance R. Which expression gives the resistivity of copper? Now remember, for resistors in parallel, if the resistors are identical, then total resistance is equal to the number of the resistors divided by the resistance of just one. So I'm going to use small letter r for the small wires because capital R has been taken away to be the total resistance. So if I have n resistors whose resistance is R, let each of these small ones have resistance R, the small ones. So total resistance is going to be the number of resistors times the resistance of each. So it means the resistance for the strands, small strands, is going to be 8 divided by R since they are 8. But remember, the resistance R for a single strand, remember also resistance is equal to rho L divided by cross-sectional area. So for one strand, R is equal to the resistivity, which let it be rho, the length, which is L, cross-sectional area is A. So it means R for total resistance for all the strands is going to be 8. 8 I will divide by R, which R is rho L over A. So A goes up, so it is 8A divided by it's 8A divided by rho times L. It is 8 divided by R. So for one, it is rho L over A. No, why should this be this? Let me check it again here. Okay, so if I have one strand, its resistance R is going to be resistivity cross-section length over its cross-sectional area A. But remember, there are 8 in parallel. 8 resistors in parallel, each having this resistance. So it means if each has this resistance and there are 8 in parallel, so it means total resistance for all the strands, R for all the strands, is going to be 8, because if I have two resistors in parallel, total resistance is going to be R times R divided by R plus R, which is R squared divided by 2R, which becomes R divided by 2. Okay, so it is going to be divided by the number. So it is R divided by 8. Okay, so not 8 divided by R. So this is going to be R divided by 8 because they're in parallel. So this is going to be rho L divided by 8A, total resistance for all the 8 strands. Then for the thicker copper wire, for the thicker strand, its resistance of the thick strand is going to be equal to rho times L. Cross-sectional area is 4A for that thick strand. Then the thick strand is again in parallel with these other 8 strands. So total resistance, this was for the thick strand. Let me write RT for the thick strand. Now we have, it's like having the resistors of the small strand in parallel with the thicker strand. They're in parallel. So we are just going to find, and the resultant is R. So we just say product over sum. So total resistance R is equal to the product over the sum. Product is rho L over 4A times rho L over 8A divided by the sum, which is rho L over 4A plus rho L over 8A. I'll just check the LCM. So this is going to be, remember this is rho. So this is rho L times rho L over 32A squared. Again, divide by LCM is 32 in the denominator, 32A squared divide by, so 32 by 4 times 32 by 4, that is 8. So this is 8A, it is 8A rho L plus 4A rho L. Okay, so 32A squared cancels out. So I am remaining with rho L times rho L divided by, in the denominator I have 8A rho L plus 4, that is 12A rho L. So this is total resistance R. So rho L cancels with that one. So I want to make R resistive to the subject. So remember R is equal to rho L divided by 12A. So making resistive to the subject, resistivity is 12AR divided by L, making the answer to be D. So I try to use long algebra, but it's fine, it's worth it. A car has sensors for detecting the light intensity and temperature of its environment. Light intensity, that is the LDR. Temperature, that is the thermistor. The sensors make use of light-dependent resistor and the thermistor. The car moves from warm, dark environment to cold. That means temperature decreases. Bright environment, light intensity increases. What are the changes to the resistance of the LDR and the thermistor? Since the temperature decreases, remember temperature is inversely proportional to resistance for a thermistor. And then light intensity is inversely proportional to resistance for the LDR. So since temperature decreases, the resistance increases for a thermistor. So resistance increases for a thermistor. And since light intensity increases, the resistance decreases for the LDR. So for the LDR, light intensity increases. Resistance decreases because it goes to a bright environment. For the LDR, resistance decreases. The light intensity for the thermistor, resistance increases. So the answer is going to be C. A student assembles the circuit shown, which row describes the state of the two lamps. Of course, this is a diode which conducts in one direction, so the lamp 1 will always light because there is current flowing through that diode. Lamp 2, this diode is not going to conduct because it is the other way around, but this diode is going to conduct, so lamp 2 will also light. So both lamps will always be on because even though this diode is not conducting, but this diode is conducting since current flows from positive, it enters from this junction, it also takes this route rather than this one. So the two lamps are always on, so the answer is D. If diode, if this diode was here and this one was there, still lamps will conduct because current will take this path, will not take the other path. The diode is forward biased. It conducts in only one direction. Kirchhoff's first law is a consequence of the conservation of which quantity? So first law is charge, second law is energy. Energy, this is second law. First law is conservation of charge. Sum of currents into a junction equals to sum of currents out of the junction. Remember, current is the rate of flow of charge. So first law is conservation of charge. Second law is summation of EMF is equal to sum of PDs in a closed loop. And remember, EMF is energy per unit charge. That is from electrical to other forms, and that is from chemical to electrical, and PD is energy from electrical to thermal per unit charge. So second law is energy, first law is charge. Okay. Three identical cells each have EMF E and negligible internal resistance. The cells are connected to three identical resistors, each of resistance R as shown. What is the potential difference across one of the resistors? So I'll just use Kirchhoff's laws. So let me choose a loop in that direction, and I'll say sum of EMFs. This is positive, positive, negative, because I'm moving in a clockwise manner. So I have E plus E minus E. That is sum of EMFs. Should be called sum of PDs. The current, of course, through them is the same. Let me call it I. So we have I times R plus I times R plus I times R. So it means we have that E, because one cancels, is going to be 3IR. So this means the current flowing in the circuit is E divided by 3R. That is the current. What is the PD across one of the resistors? V is equal to I times the resistance, which is E, divided by 3R times the resistance, which is R. So R cancels out, and you have 3E over 3. So the answer is going to be B. In the potentiometer circuit shown, the reading on the ammeter is 0. So that means there is balance. So let me call this one Z, Y, and I call this one X. The light dependent resistor is then covered, and the ammeter gives a non-zero reading. So the light dependent resistor is covered, which means resistance, light intensity decreases, resistance of the LDR increases. What does that mean? The PD across XY increases. Okay. Which change could return the ammeter reading to 0? The PD across XY has increased. And remember, for balance, the PD across the LDR should be equal to the PD across the LDR is the same as the PD across XY. Those two parts are in parallel. Now note that the resistance has increased. When the resistance increases, it means the PD across, this part means the PD across the LDR has increased. So PD across LDR has increased, which means PD across XY has actually increased. The PD across XY has increased. But remember, in comparison, the PD across XY divided by the power supply, which is the PD across ZY, should be equal to the length XY divided by the length YZ or ZY. The PD across ZY is the EMF of the power supply, which is constant. The length ZY is also constant, so this is constant, this is constant. So since this has increased, since Vxy has increased, the length xy should also increase. The length xy should also increase, and the only way it is going to increase is by shifting the sliding contact to the left. So which change could return the ammeter reading to 0? To get balance again, we are going to move the sliding contact to the left, so the answer is going to be C. Since the PD across xy has increased, for us to have balance, so that the PD across xy is the same as the PD across the LDR, we should move the sliding contact to the left because the PD across xy depends on the length xy. So moving the sliding contact to the left increases xy to restore balance. So the answer is C. Okay, what are isotopes? Of course, isotopes, this is same proton number, different neutron number, different nucleon number. So nuclei of different elements, they are of the same element. They are not different elements. Nuclei of the same element, but with different neutron numbers. So the answer is going to be C. Nuclei of the same element, but with different proton number. The number of protons are the same. Remember, for example, we have helium 4-2 and helium 3-2. Same proton number. So this is the same element because they will behave the same way since the proton number is the same, but they have different neutron numbers, which makes nucleon numbers to be different. A neutron 10N is fired at a uranium nucleus. So we have uranium 23592 plus a neutron N10. The neutron is absorbed by the nucleus, which then splits to form barium. So it is forming barium 14156 plus krypton, which is 9236. What is the number of neutrons emitted when the uranium nucleus splits? So it means plus a given number of neutrons, 10. Let me put here A. So we want to find A. Let me put here X. Let me use X. We want to find X. So by conservation of proton number, this is 92 is equal to 56 plus 36 plus X times 0, that is 0. So proton number is balancing. I can't rely on proton number. By conservation of nucleon number, I have 235 plus 1, which is 236 on the left, should be equal to 141 plus krypton, which is 92 plus X times 1, which is X. So I have that 236 is equal to, I think this is 233 plus X, which makes X to be equal to 3. So the answer is 3. And lastly, a pi plus meson has a charge of positive E, where E is the elementary charge. It consists of an up quark and one other quark. What could be the other quark? So remember, a meson has a quark plus an antiquark. So if it has an up quark, the other one should be an antiquark. First of all, it should be an antiquark. But remember, the charge is plus E. So the other one cannot be charm, first of all, because charm is not an antiquark. It can't be bottom. Bottom is not an antiquark. So we want to have a charge which is positive E. Remember, an up quark has a charge of positive 2. An up quark has a charge of positive 2 over 3E. Then the other quark we don't know, so we say positive 2 over 3E plus the other quark, which we don't know, should be equal to positive E. So what is Q? I'm finding the charge for the other quark. So Q is going to be E minus 2 over 3E, which is equal to, I think this is minus 1, no, it is plus 1 over 3E. And plus 1 over 3E, this is an antiquark, which is either anti-down or anti-strange or anti-bottom. So the answer is going to be A. Anti-up would give us a 0 charge, yet it is supposed to be positive E. Okay, so I think I kept time, and that marks the end of this paper. See you in the next paper. Until next time, bye-bye.